Hey, this is Mr. Hansen. I want to look at sine function and cosine function with you today. And as we've done in the past with lots of functions, it'd be nice to actually graph these functions and get a picture of what your inputs and outputs look like all together on a xy plane. So that's kind of where we're headed with this. We're going to use a little bit of knowledge or information that we've gleaned from sine and cosine and from the unit circle to kind of build this graph. So let's take a look. I've got a t-chart here. My input is an angle, and then my output is the ratio, the sine ratio for that angle. And remember, sine is always just opposite over hypotenuse. So we're talking about our angle is going to be from the origin, and we're just and our it's a unit circle, so that's 1. So sine is really just the height of our triangle right there. So at sine 0, there's really no triangle. Also, it's the y coordinates. So I'm just going to write xy here and cosine theta and sine theta there. So the y coordinate is sine theta. Okay. So let's take a look at this. I plug in 0 for my angle, and you might remember we're just plotting an angle right there with an initial ray, terminal ray, 0 degrees. And so the output is 1 comma 0 is the ordered pair, and the output would be 0. And then at 30 degrees, you can see that you might remember the 30, 60, 90 triangle, and we've got square root 3 over 2 and 1/2. So this part is half as big as the hypotenuse there. So at 30, we've got 1/2. And then at 60 degrees, notice we've almost reached the top there of the circle. At 60 degrees, we've got square root 3 over 2, which is 0.866. So 0.866 square root 3 over 2. Same thing. Okay, and then at 90 degrees, we've got 0, 1, so sine has reached 1. Okay, so up to this point, we are increasing. What's going to happen next? Well, you should probably realize that as we keep going in a counterclockwise direction, we're going to decrease. So let's go to 120 degrees right here. And you might notice the height for 120 is the same as the height for a 60 degree. And this is kind of the reference angle connection we were making the other day. So the height's going to be 1/2 there. I'm sorry. 0.866 there, 0.866, or square root 3 over 2. And then at 150, that's like a reference angle to 30. The height there is going to be 1/2. And then at 180, we're back down to, this is -1, 0. We're back down to 0. All right, so let's just take a look at what we've got so far on the graph. 0, 0, this is 1, that's -1. 0, 0, and at 30 we're at 1/2, and at 60 we're at 0.866, and at 90 we're at 1. And then we come back down, 120 we're at 0.866, and then at 150 we're at 1/2, and 180 we're at 0. So it's kind of like just going up the hill, down the hill. Okay, let's see what happens next. 210. So 210, let's kind of complete this circle like that. And at 210, that's the reference angle with 30 again. So about right there at 210. We're going to be, this time we're going down this much instead of up that much. So we're going to go -1/2, -1/2. And then 240 is going to be kind of like reference angle with 60. So, and 60, you might remember, was square root 3 over 2. I ought to put these in 1/2 and square root 3 over 2. So 240 is reference angle with 60, so we got negative square root 3 over 2, which is -0.866. And then at 270, we're at 0, -1, so it's -1. At 300, we start to increase again, so it's -0.866 again, another reference angle. At 330, it's going to be -1/2. And then at 360 is going to be 0. So let's just go ahead and kind of finish this up. So from 180 we went to 210, that's negative 1/2, 240, negative 0.866, 270, negative 1, negative 0.866, 1/2, and back to 0. And there are a bunch of points in between. We just used some easy points with a 30, 60, 90 triangle, but as you kind of take that radius and sweep out the circle, you'll have an infinite number of points. And so this is kind of a continuous thing here. Kind of go like this. And there you have it. That's one cycle of sine. Now you guys might remember coterminal angles. We could go, instead of 360, we could go, or instead of 30 degrees, we could go 390. So here's 390. It's going to be the same exact thing as 30 from over here. So here you have 390. It's also 1/2. And instead of 60, 60 plus 360 would be 420. It'd be right here, and so on. And you can kind of see that this wave pattern is just going to continue. It's going to repeat on and on and on and on. Up, down, up, down, up, down. So some important things to think about when we're thinking about this. First of all, let's talk about the domain and range. You can put in any number for an angle. You could even put in negative numbers, and you'd have a kind of go like that. But you can put in any number you want for the angle. But the thing you're going to get out is always going to be between 1 and negative 1. So the domain is negative infinity to infinity. So the inputs, the angles, you choose any angle you want, but the range is going to be negative 1 to 1. And the reason why is, if you think of the sine of a triangle up here, we've got opposite over hypotenuse, and the opposite will never be larger than the hypotenuse. So that's why we've got that range right there. Okay, I want to take a break before we get into cosine, and I want you to think a little bit about where this might come up in the real world, how this might help. So let me go back here. We've got this just a few pictures here. Wave patterns. Let's talk about wave patterns. I've got a heart here. What does a heart have to do with wave patterns? Maybe you're thinking about something like this. And hopefully it doesn't go like this. That means it kind of flat lines and the person dies. But when a person pumps blood through their body with their heart, it goes ba-bump, 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 ba-bump. And so we've got a wave pattern of the blood flowing back and forth, or the blood going through and then pumping, going through, then pumping, and so on. Okay, here we have an ear, if you can recognize that. And what does an ear have to do with wave patterns? Well, sound travels in waves. So again, we've got these waves here, and people study the waves, and the waves could look different. They could have a higher frequency or a lower frequency, meaning they occur more quickly over time or slower, and they could have a different amplitude, meaning they could have higher or lower sounds. But anyway, sound travels in waves, and then light travels in waves too. I'm not a scientist or an expert on this, but I know at least enough to know these basic things have wave patterns. Okay. And one last thing here. This is a picture of my pantry with food in it. So at the beginning of the month or the week, I buy groceries, and then I stock them on the shelf. So kind of like this. And then over the week, we eat the groceries. They slowly go away, and then I stock them on the shelf again, and they slowly go away, and do it again. And I've been doing this for years and years and years, and it makes a repeating pattern. So we can also use a different version of sine function to kind of estimate that repeating pattern. So sine functions would be able to model all of these patterns here, these recurring patterns that are going on. That's why it's such a powerful thing, and there are plenty of other things that sine function can model too. All right, let's look at cosine. Cosine is not much different than sine. Let's take a look here, but you might remember cosine was adjacent over hypotenuse, so we've got the x over the hypotenuse, the adjacent over the hypotenuse. So when we do our unit circle on this one, we're going to be talking about the hypotenuse will be 1. And so we're going to be talking about how far to the right or left we are instead of how far up or down. And that's going to be the x-coordinate. So here we have 1, 0. So at 0 degrees, we are at 1. At 30 degrees, right here, you might remember square root 3 over 2 and 1/2. At 30 degrees, we are at square root 3 over 2, which is 0.866. So the x-coordinate is really quite large right there. And I'll just kind of highlight that in red right there. And then at 60 degrees, the x-coordinate is much smaller, so it's at it's 1/2 of the hypotenuse. So 1/2. And at 90 degrees, so let's do this 1/2 square root 3 over 2. And then we've got 0, 1. So now we're at 0. And at 120 degrees, we are going to be at, remember this is a reference angle with the 60. So we're at -1/2 now. So -1/2. And then 150 degrees, negative square root 3 over 2. Negative because we're kind of going negative to the right, and that's what we're measuring is that red there. Okay, so -1/2, negative square root 3 over 2, and then negative 1 here. This is -1, 0. And then we're going to go back down to negative square root 3 over 2, and then -1/2 again. Let's see, did I do that in the right order? 210. Let's just draw that one out to help me. 210 is 180, so that's the opposite 30. Yes, negative square root 3 over 2, -1/2. And then at 270, we're at 0 again. And then an interesting thing happens. Cosine starts to turn positive right here at 300. So at 300, that's reference angle with 60 degrees. So we're gonna have positive 1/2. I don't know why I put 0 and -1 there. Let's cancel that out. And then at 330, we're gonna go right here. So cosine's gonna be positive square root 3 over 2. And then at 360, we're back to positive 1. So let's go ahead and graph these, and then we'll call it good for this video. So 0, we start at 1 here, and then 0.866, and then 1/2, and then 0, and so it kind of goes like this. And then at 120, we're at -1/2, and then negative square root 3 over 2 and -1, so it kind of goes like this. And then we go negative square root 3 over 2 again, and then -1/2 again, and then 0, and then 1/2, and square root 3 over 2, and 1. So it kind of looks like this here. And that's the cosine function. And let's just discuss domain and range here. Again, the range is -infinity to infinity, and the domain is just going to be -1. So this is this is a domain, and the range is just going to be -1 to 1, like that. And if we were to overlay the sine function on this, it's kind of interesting. All this is it's a transformation of the sine function 30 degrees. Notice that if we go from x to y right here, we're going 30, we end up with the same thing. That's like going from 30 to 60 degrees. And so the idea is they're really the same pattern. One's just occurring 90 degrees later than the other one. So that's about it for sine and cosine. Hopefully, let's just make this point here that it does go on and on and on like this. Okay. Hopefully that helps you kind of understand what a sine graph looks like and what a cosine graph looks like. Thank you and have a good day.